All right, let's talk about circles. Probably the most straightforward, basic, easy of the conic sections. Remember, a circle is formed when you intersect a cone. So here's this cone, and you intersect the cone with a plane, and the plane is parallel to the base of the cone, and that's how you get a circle. That's a really bad drawing, but hopefully you can kind of picture that in your head. All right, so with a circle, here is a circle drawn in the coordinate plane. I'm going to put the center in the first quadrant. Here's my circle, very badly drawn. The center is at some point, I'm going to label this, the center is going to be at some point, HK. This center is shifted to the right and up. And then the other thing that I need to know about this circle is the radius. And then the radius is just the distance from the center to any point along the outside of that region. All right, the standard form of a circle looks like this. X minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. And that's pretty much the size of that. For example A, let's write the equation of a circle with a center at -4, 3 and a radius of 4. So using that equation that I have up above, that's going to kind of be my guide. So x minus, my center is hk, so x minus -4, quantity squared, plus y minus 3, quantity squared, is equal to 4 squared. I'm going to simplify this a smidge and write this as x plus 4, quantity squared, plus y minus 3, quantity squared, is equal to 16. Done. Let's take a look at example B. In example B, let's identify the center and the radius. So you can probably do that pretty straightforward. Oh, sorry. X minus 16 quantity squared, y plus 9 quantity squared equals 144. So I recognize this as x is equal to 16, y is equal to -9, so shifted to the right and down, making my center 16, -9, and then my radius, well, r squared is 144, so that means that r was just 12. My radius is 12 units. Last example, let's identify the center and the radius and then make a quick sketch. So this is what we call general form. We're going to have to do a little work here. Let's begin by sorting down our variables. I'm going to collect the x squared and the 8x, and then over here I'm going to do y squared minus 10y. I'm going to leave some space and I'm going to call this equal to 8. So what I need to do now is I need to complete the square twice. Yay! So what will complete the square here? Half of 8 squared. Half of 8 would be 4. 4 squared is going to be 16. But if I add something to this side, I have to add it over here as well. Add 16 to both sides. Again, I'm trying to keep that teeter-totter balanced, that teeter-totter. If I add something over here, I have to add something over here. In the previous video, our equal sign separated y from the rest of it. So we added and we subtracted to keep the teeter-totter balanced. All right, anyway, back over here. What's going to complete the square here? Well, half of -10 would be -5, and -5 squared would be 25. So plus 25. Now this factors into x plus 4 quantity squared. You see why we completed the square? So we could rewrite this. And then this would be y minus 5 quantity squared is equal to, well, 30, 41 plus 8 is going to be 49. Let me check that again. 16 and 8 would be 24. Yep, 49. All right, so what's our center? What's our radius? And then let's make a really quick sketch. My center would be to the left 4 and up 5. So thinking in terms of zeros, that would be like x equals -4, y is equal to +5 in terms of a 0. So left 4, up 5, and then the radius is going to be, remember that your radius squared is 49, so my radius would just be 7. All right, rough sketch time. And I don't know if you wrote this down, you don't need it. I'm going to erase it. I was just reminding you how to complete the square. All right, coordinate plane, go to the left 4. I'm going to go up 5 and plant my center. And then I'm going to go 7 units in each direction. So I can go up 7. That'll take me to about 12, so negative 4, 12. And then I'm going to go down 7, so that's just going to take me down to negative 2, 5, 6, 7. I'm going to go over 7, so that takes me over here to 3, and it takes me back here to negative 11. So notice that I just added 7, I subtracted 7, I added 7, and I subtracted 7 in all the directions. Now, I never made my point over here. I made my point over here. All right, connect those dots. Oh, what an ugly circle. But good enough. We went 7 in every direction, and that gave us a radius to kind of use as a reference point. So that's all I have to say about that. Tomorrow, we will look at more examples of writing equations and graphing circles.